Water conservation techniques. Water. Glue आवाज थोड़ी कम करना. Conservation techniques. In spite of harnessing the maximum water potential by constructing large dams, reservoirs, and installation of the shallow and the deep tube wells, the world in general and India in particular are faced with acute scarcity of water in the view of growing population and competing demand from industrial, agriculture, and domestic sectors. It is therefore imperative that existing resources, including rainfall, are optimally used and properly conserved, and hence water conservation is the need of the hour. There is now a growing awareness in most parts of the world regarding the need and importance of water conservation in order to ensure long term sustainability. The water conservation in rainfed areas assumes added significance due to paucity of the exploitable water, paucity of exploitable water resources. Rainwater conservation, water harvesting hold the key to agriculture sustainability in these regions. Then we have the water conservation. Water conservation measures in action, technology, or improved design or process implemented to reduce water loss, waste, or overuse. It can be expressed in the following ways: reduction in water loss, water wastage by the behavioral change or device used in domestic works and in daily needs. Reduction in water use accomplished by the implementation of technological advancement in water conservation or water efficiency, measures in industrial processing. Improved water management practices that reduce or enhance the beneficial use of water in agriculture production or reduce the irrigational demand. We have the benefits of water conservation. Water conservation refers to the reducing use of fresh water through technological or social methods. Following are the main goals of water conservation, like sustainability, energy conservation, habitat conservation. In order to ensure availability of the water for future generations, withdrawal of fresh water from an ecosystem should not exceed its natural replacement rate. Then the energy conservation, water pumping, delivery, and the wastewater treatment facilities consume a significant amount of energy. Efforts should be made to use efficient and cost-effective methods. Then we have the habitat conservation. Minimizing human water use helps to preserve freshwater habitats for local wildlife and migrating waterfowl, as well as the reducing the need to build new dams and other water diversion infrastructure. The adoption of water conservation, water harvesting techniques. Water conservation, water harvesting at micro or macro level leads to sustainability in water sector for mitigating water scarcity and drought effects. India is characterized with wide variations in the physiographic, climatic, soil, environmental, and the socio-economic conditions. Therefore, rainwater harvesting technology is highly location specific. The various rainwater harvesting practices in vogue may be broadly grouped as the in situ retention of rainfall on the land itself by agronomic or mechanical measures, harvesting surface runoff from land surface and its storage for later use, diversion of perennial surface or subsurface water source in storage structures and rooftop rainwater harvesting. The in situ water harvesting practices include bunding and terracing, vegetative barriers, counter bunding, counter ditching, leveling, counter farming, cover crop and mulching, Conservation, tillage, and deep plowing. The surface runoff water can be achieved through nadis, which is the dugout ponds, tankas, khadins, ahars, haveris, divergent ponds, and rooftop rainwater systems. The stream flow runoff harvesting is practiced through nala bending, check dams, stop dams, bandaras, percolation tanks, ponds, and nadi subsurface barriers, diaphragm dams, bandaras are used for subsurface flow harvesting. Indigenous rainwater harvesting and conservation techniques adopted in different parts of the country, depending on the agroclimatic condition, have been discussed. The water conservation in various sectors, namely domestic, industrial, and agricultural, needs to be practiced vigorously for long-term sustainability. Different water conservation strategies for each sector need to be identified and implemented. Then we have the domestic water conservation. Water conservation programs are typically initiated at the local level either by the municipal water utilizers or local governments. Common strategies include public education campaigns, social water awareness, progressively charging higher prices, increases in the water use, subsidized for shower head and toilet retrofits, and toilet and the seasonal restrictions on lawn sprinklers, on lawn sprinklers. Cities in dry climates often require or encourage the natural landscaping in new homes to reduce outdoor water usage. One of the fundamental conservation goals is universal metering. Water metering can reduce water consumption by 20 to 40% in addition to raising consumer awareness of their use water use. Metering is also an important way to identify and localize water leaks. Then we have the optimization of water use by personal habits. Do not waste water just because someone else is footing the bill. Conserve water because it is the right thing to do. Do not leave the tap running while brushing your teeth or shaving. Open it only when you require it. Use a washing machine that does not consume too much water. Water coolers require a seasonal maintenance checkup. For more efficient cooking, check your pressure cooker annually. Soak your pots and pans instead of letting the water run during cleaning. Do not water your lawns on windy days. At the end of the day, if you have water left in your drinking water bottle, do not throw it away. Pour it over some plants, reducing water losses in water supply and sanitary fittings. Repair dripping walls by replacing washers. If your wall is dripping at the rate of the 1 drop per second, nearly 8,000 liters of water per year will be wasted, resulting in increase of the cost of the water and fewer utilities. Low flush toilets, composting toilets, and waterless urinals help in considerable water saving. Helps in considerable water water considerable water saving. Western toilets use large volumes of water. Low flow shower heads, also called energy efficient shower heads, should be used. Faucet aerators. Faucet aerators break water flow into fine droplets to maintain wetting effectiveness while using less water. They reduce splashing while washing hands and dishes. When washing dishes by hand, do not let the water run while rinsing. Fill one sink with wash water and another with the rinse water. Reuse and recycling of the water used in non-consumptive requirements. Drain water instead of the disposing of may be used for watering a plant or garden or cleaning. Reuse wastewater through purification at a water treatment plant. Utilize the water used for washing the vegetables and fruits for irrigation of flowers and ornamental potted plants or for cleaning. Then the industrial water conservation. Water is essential to our health and the health of our economy. As a major use of this precious resource, industry has an important responsibility to practice water conservation techniques, which can provide immense benefit. By reducing the use of water, industries can protect the environment and gain a competitive edge by reducing their own cost of doing business. Water use for industries, metal, wood industries, paper, chemical, textile, and the oil are major users of the water. Probably every manufacturer products use water during some part of the production process. Industrial water use includes water used for fabricating, processing, washing, diluting, cooling, or transporting a product, incorporating water into a product, or for sanitation needs within the manufacturing facility. Food, paper, chemicals, refined petroleum, or primary metal industries are large amounts of water. Water requirement in industries. Earlier, the water requirement of the industries in India is very small compared to demands of other sectors. With the rapid growth in population coupled with overall economic development due to industrialization, water requirement for sector has increased many-fold. Techniques for achieving water conservation. The amount of water consumed for the products varies widely depending upon the process used, plant efficiency, technology employed, degree to which water is recycled, and other factors. There are no fixed norms for water demand of industries, however, based on the technology used, selection of plant and process, practice in providing maximum recycling to reduce demand and pollution. A range of values is specified. Policy for industrial water. Water use management is necessary to conserve our precious natural resources in which both public and private sectors have an important role to play. The water use efficiency programs reduce water demand, effective water saving and wastewater treatment, reduce environment impact and sustain water quality. Effect water saving and wastewater treatment, reduce environment impact and sustain. Yeah, industrial water conservation programs benefit the industrial owner and managers in terms of the enhancing their knowledge on the efficient water use practices and effluent disposal, water auditing, and the accounting techniques. Technological advancements in industrial water and the wastewater treatment and industrial legal issues, industrial water conservation optimization, rainwater harvesting, need for efficient and innovative water use strategy. Water availability should be one of the main criteria while deciding the location of new highly or moderately water intensive industries. The Ministry of Industry, in consultation with the Ministry of Water Resources, should fix upper limits of water requirements for the production of various industrial commodities. Substantial water and the cost savings could be achieved by treatment of the wastewater and changing industrial processes. The existing system of subsidies and the tax structure on investment in pollution control, water conservation, water recycling technologies need to be periodically reviewed. A significant and punitive variable tax needs to be imposed for creating pollution. And tariff rates need to be prescribed to force industries to introduce technological interventions leading to reduced use per unit production. For effecting maximum conservation, production processes have to be modified to have lesser generation of effluent water. Pollution controlling and waste reduction. Selection and zoning of industries associated with potential risks, especially those releasing toxic waste, need a thorough analyzing and planning before they are set up in any water basin. A policy zoning the water basins according to the types of industries, quantity of water consumed to discharge needs to be laid down. The minimum national standards evolved by the Central Pollution Control Board. Based on minimum treatment concept, HAP will be strictly followed while clearing proposals for locating industries in polluted stretches of water bodies. The common effluent treatment plant schemes have already been implemented in some states. States may also have to come out with their industry policy based on availability of water in certain sectors in industry. There should be a comprehensive and periodic water consumption and discharge audit of industries for effective management strategies. Then we have the wastewater recycling through industrial eco parks. This involves the creation of artificial wetlands using aquatic plant root zone system to treat sewage waters up to minimum levels of recycling in the irrigation and horticultural sectors and possibly some industrial estates. The system utilizes the roots of certain type of plants such as duckweed, water hyacinth, pennywort. They help in the growth of bacteria which utilizes the nutrients present in the effluents and for the transfer of oxygen. Industrial water conservation, a need of the hour, and industry not only results in increased water use and considerable waste discharge to the hydrologic system, but also change characteristics of the surface of groundwater resources. Therefore, water resource utilization, conservation, and reduction or elimination of the water discharges should be practiced effectively and realistically for long-term sustainability. Then we have the agriculture water conservation. The agriculture sector is the mainstay of economy and agriculture consumes over 70% of fresh water. It is absolutely essential that water is efficiently used and conserved in order to command more area with the limited water resource. The share of water in agriculture is likely considerably decreased due to competing demand from other users like domestic and industry. Efforts should be made to use very drop of water efficiently for maximizing crop production. Farmers should be forced to grow more water efficient crops and adopt less wasteful irrigation techniques. The water used in agriculture, surface and the groundwater resources in India have been exploited to the maximum extent, and there is no further possibility to enhance it. The groundwater levels in the most parts of the country have been depleting due to overpumping of groundwater for meeting demand of high water requiring crops. The situation have been further compounded due to erratic rainfall distribution and groundwater development exceeding the natural recharge. It takes an enormous amount of water to produce crops. It is 3 to 5 meter cube water to yield just 1 kilo of rice and 1 meter cube water to produce 1 kilo of wheat. It is therefore of the paramount importance to alter the existing cropping pattern from high to low water requiring crops and use the water resources, including rainwater, in the most optimal way by adopting efficient on farm water management practices. Water conservation techniques for agriculture. Water use efficiency needs to be enhanced by using minimum water, resulting in the maximum productivity. In irrigated agriculture, water needs to be used as efficiently as possible along with adoption of recommended packages of practices, such as use of nutrients, pest disease, and weed control so that it results in the maximum production. In rain-fed agriculture, the soil moisture needs to be stored and conserved for the maximizing the crop productivity, which is presently very low as most of the area in the country is still rain-fed. The crop productivity in such areas need to be enhanced and sustained in order to meet the food requirement of ever growing population of the country. in both irrigated as well as rain-fed areas. Utmost effort should be made to use existing water resources, including rainwater, efficiently and optimally and conserve soil moisture for long-term use. In irrigated agriculture, particularly in semi-arid and the arid regions, the following measures help in reducing water losses and to conserve soil moisture. Mulching, that is the application of organic or inorganic materials such as plant debris, reduces evaporation losses and improves soil fertility. And the field should not be left fallow for the long periods of times in order to reduce the water losses by evaporation. Plowing helps in the conserving soil moisture and retaining more water, thereby reducing evaporation. Shelter belts of trees and bushes along the edges of the agricultural fields slow down but the wind speed and reduce evaporation and erosion. Planting of trees, grass, and bushes breaks the force of rain and helps rainwater penetrate the soil. Artificial surfaces such as netting surface traps or polyethylene sheets can be exposed to fog and dew. The resulting water can be used for crops. And the irrigation efficiency. Reservoir storage efficiency, water application efficiency, water storage, water distribution, water use efficiency.